So this is the last part of section 2.2. At some point I thought I might be able to do it in 2 videos, but I think 3 videos just feels like it makes more sense. So problems 33 through 42 want us to find equations of slopes of lines and equations for lines. And that's real easy to do because to find the slope of a tangent line, you just take the value of x and plug it into a derivative. So each of the problems between 33 and 42, it gives me a function and a value of x. And it has a part A and a part B. Part A wants me to find the slope of a tangent line at the value of x that's given. And to find the slope of a tangent line, I just simply take the value of x that's given and plug it into the derivative. So plug or substitute the value of x into the derivative. So part A, the answer is just going to be a number, and it's going to be like m equals something, and whatever the slope of the tangent line is. So for each problem between 33 and 42, there's a part A, where we need to find the derivative and plug the value of x given into the derivative. Part B, we want to find an equation of a tangent line. And I'll get to that after I do a part A. So before I jump into that, let me do part A of 34. So for problem 34A, it asks me to find the slope of a tangent line. And in order to do a slope of any tangent line, I need to know a derivative. So apparently I may have computed this derivative already. Maybe it's like problem 2 in this section, but I'm going to keep practicing my derivatives. So this right here is multiplication, and I can find any derivative when there's multiplication by using the product rule. So I'm going to find the derivative real quickly. The first factor is 3x minus 4. The second factor is 5x minus 8. I'm going to use the product rule. And the product rule requires me to know each factor and its derivative. So the first factor was the quantity in the first parentheses. The second factor is the quantity in the second parentheses. The derivative of the first factor is just going to be 3. The first term is the first power term. This derivative is the number in front of the x. The second term is the constant. Its derivative is 0. For the derivative of the second factor, the derivative of 5x is just 5. The derivative of 8 is 0. And remember, the product rule says the derivative is the first factor times the derivative of the second factor plus the second factor times the derivative of the first. So I'm going to find the derivative real quickly, and I'll use it to find the slope of my tangent line. So first factor, 3x minus 4, put it in the parentheses because it's a binomial, times the derivative of the second. I could write it before the parentheses, but I'll write it after. And then plus second factor, 5x minus 8, times the derivative of the first, which is 3. Clear the parentheses. 3x times 5 is 15x, minus 4 times 5 is minus 20. 5x times 3 gives me a plus 15x. Minus 8 times 3 is minus 24. Combine like terms. 15x and 15x is 30x. And minus 20 and minus 24 have the same sign, so I add the numbers and keep them negative and get minus 44. So now I'm going to write down get the answer to part A. To find a slope of a tangent line at the given value of x, I need to find the derivative and then take the value that's given to me and plug it in for x. So I'm going to say m equals 30 times 3 minus 44. So if you plug a value of x into a derivative, it gives you the slope of the tangent line for that value of x. So the answer to part A, the slope of the tangent line is going to be 46. So for part A, where I'm asked to find a slope of a tangent line, the algebra is to find the derivative using whichever rule is necessary, and then plug the value of x that's given into the derivative, and that will give you the slope of the tangent line. Done with part A, now I'm going to move on to part B. For part B, I'm finding an equation of a tangent line. So 34b, if I look at the instructions, it says find the equation for a tangent line. And in order to find an equation of a tangent line, I need to know a point on the line and the slope. The slope I get by plugging a value of x into the derivative, which I did in part A. A point, I don't need the derivative. So for slope, I use the derivative. I didn't give you a slope, so I needed to use the derivative to find the slope. I give you the x coordinate of a point, but I didn't give you the y. And in order to finish up problem 34b, I need to finish the point. I gave you half a point. To finish up finding the point part of what's needed to find the equation of a tangent line, I need to use the original function. If I take the value of x that's given and plug it into the derivative, I get the slope of the tangent line. If I take the value of x that's given and I plug it into the original function, I get the y coordinate of the point that has an x coordinate that's given to me. So now, to finish up problem 34, I'm going to find the y coordinate of the point by using the original function and the value of x that's given. So I'm taking the two x's that are in the original function and I'm plugging in 3 for them. And I'm just going to do this on my calculator because I feel like I'm going to make a mistake if I don't. So I'm going to go 3 parentheses 3 minus 4 parentheses 5 parentheses 3 minus 8. And I get y equal to 35. So that's the y coordinate of my point. That's right. So I'm going to write that up here. So in order to do part B, in order to find an equation of any line, you need a point and a slope. Part A, the algebra that I'm asking you to do to part A gave you the slope. The problem itself gave you half of the point, and the algebra that I just did by plugging the number that's given into the original function gives me the y coordinate of the point. I'm not done with 34b, but I'm basically there because now I have everything I need, and now I'm going to use the y minus y1 equals m times x minus x1 formula to get the answer I'm looking for. So I'm going to take the 3 values I have, 3, 35, and 46, plug them into the formula where they go to get my equation. In for y1, I'm going to put the 35 that I just figured out, the y coordinate of the point. In for m, I'm going to plug the value that I got in part A. And in for x1, I'm going to give the number that's been given to me. I'm going to clear the parentheses on the left-hand side. I'm going to go 46 times x is 46x. And 46 times minus 3 is apparently minus 138. And then I'm going to add 35 to both sides. I'm going to go minus 138 plus 35. And get y equals to 46x minus 103. And that's going to be the answer to part B. So for my part B, is that readable? I'm going to say the answer is y equals 46x minus 103. So each of the problems up between 33 and 42 are exactly this style of problem. The steps will be exactly the same. To do part A, I'll find the derivative, plug the value that's given for the letter into the derivative to give me my slope. For part B, I'll give the value that's given for the letter, plug it into the original function to give me the y, and then use the formula. So just to make your life easier, let me do 35 with you and not do 36, just in case you need some help following along here. So you've probably already done this derivative, so you don't have to find the derivative again, but I'll find it. So I'm going to do 35a, and for 35a I need to find the derivative and plug 4 into the derivative. To find the derivative, I need to know each factor. The first factor is 2t minus 1. The second factor is 3t plus 5. The derivative of the first is just 2. The first piece is the first power term. Its derivative is just a number in front of the letter. Second piece is a constant. Its derivative is 0. The derivative of the second factor is just going to be 3. First piece is the first power term, its derivative is the number in front of the letter. The second piece is a constant, its derivative is 0. So the derivative using the product rule is going to be first factor, 2t minus 1, times the derivative of the second, plus in the product rule, minus in the quotient rule, plus second factor, 3t plus 5, times the derivative of the first factor times 2. So this is going to give me, the derivative is, let me see, 2t times 3 is 6t, minus 1 times 3 is minus 3, 3t times 2 is 6t, 5 times 2 is 10. Combine the 6t's to get 12t. I'm doing this a lot faster, assuming you're getting kind of good at these. And the minus 3 and 10 have opposite signs. You subtract and take the sign of the larger and get plus 7. All that work is just to help me be able to find the slope in 35a. So in 35a, I'm going to take the value that's given for t and get the slope. So the m is going to be 12 times 4 plus 7, which I think is 55. I make so many mistakes when I don't use my calculator. Probably have already made a mistake on this video, but I'll live with it. So the answer to 35a is going to be m, the slope of the tangent line at t equal to 4 is 55. I move on to part B. For part B, I need a point and I need a slope to find an equation of a line. 35b wants me to find an equation of a tangent line. I found the slope in part A to be 55. The number that's given after the semicolon is the x-coordinate of the point. To get the y-coordinate of the point, I'm going to plug the value that's given into the original function. So to get the y-coordinate of the point, I'm going to take each of these t's in the original function and go and change them to 4s. And now I'm going to do that on my calculator. The y-coordinate of the point I don't care to do by hand. So the y-coordinate of the point, I'm going to get parentheses 2 times 4 minus 1 times 3 times 4 plus 5. I think the y-coordinate of the point is 119. Because that's 7 times 17. Yeah, so part A is way more work than part B. Part A, you find the derivative, take the value that's given for the letter, plug it into the letters in the derivative. That gives you the slope with the tangent line. Part B asks me to find an equation of a line. To find an equation for a line, you need a slope. You found the slope in part A, and you need a full point. The x-coordinate of the point is given. The y-coordinate of the point you get by plugging the x-coordinate in for the letter into the original function. Plugging numbers into the derivatives gives me slope. Plugging numbers into the original functions gives me y-coordinates. Now I'm just going to use the y minus y1, and then for y1 I'm going to plug 119 equals m, I'm going to plug 55, times x minus x1. I should probably use t here because a variable in the problem is t, but boy, I'm not going to do that. That's because maybe overcomplicated. So now I just use the formula y minus y1 equals m times x minus x1. So y minus the y-coordinate of the point equals m times x minus the x-coordinate of the point. Definitely could have used the t there because there's a t given. I'm going to multiply the 55 times 4 and get 220. So clearing the parentheses on the left-hand side, I multiply 55 times x and get 55x. And then 55 times minus 4, I get minus 220. And I'm going to add 119 to both sides. And that's going to give me y equals 55x. And now I'm going to do minus 220 plus 119 and get minus 101. And that's going to be my answer to part B. So for part B on 35, I'm going to get y equals 55x minus 101. Of course, assuming I made no silly math errors along the way. So just a few more to go. 3 more specifically to go. And let me teach you a shortcut for the next 3 problems, just to speed up the work. You can do everything by hand. On the test, I'm going to have you do it by hand, so why should I show you the shortcut? I should, forget it. Let me just do it the long way. Let me do 38a, long-ish way. So first I need to find the derivative so I can find the slope. So I need first factor. There's a shortcut to do this on my calculator that I'm wanting to show you, then I'm almost thinking not to do that because then students will just do the shortcut and not do the math. So there's my first factor, second factor, and then derivative of the first. The derivative of 4x cubed is just 12x squared. I multiply the 3 and the 4, lower the exponent by 1. The derivative of the second, the derivative of 3x squared is 6x. The derivative of 7x is 7. The derivative of minus 5 is 0. So for 38a, the derivative is first factor, 4x cubed, times derivative of the second, 6x plus 7, plus second factor, 3x squared plus 7x minus 5, times the derivative of the first. It's almost easier to write it first as opposed to second. You can always, when you have the multiplications, you can flip-flop the multiplications like I was doing with the quotient rule. And I'm going to flip-flop that just to make it easier for me to do. Yuck. So now I'm going to get y prime equals to 4x cubed times 6x is 24x to the 4th. 4x cubed times 7 is plus 28x cubed. 12x squared times 3x squared is plus 36x to the 4th. 12x squared times 7x is plus 84x cubed. And 12x squared times minus 5 is minus 60x squared. Oh, this is disgusting. Now I'm going to go 24x to the 4th plus 36x to the 4th. This is getting too fast, but the video is kind of getting long, and I don't want to drag it out much longer than I have to. Now I'm going to take the 28 and the 84x cubed and combine them. And get 112x cubed. And then the minus 60x squared is just going to stay. I don't really need to pull out the common factor because I'm just finding the slope. And And I'm going to find the slope by plugging 1 in. And plugging 1 into a non-factored version will give me the same number as plugging 1 into a factored version. So I'm not going to take the time to pull out the common factor. If I was only asked to find the derivative, I'd probably pull out the common factor. But since I'm not asked to find the derivative, I'm just asked to find the slope. I'm finding a not completely simplified version of the derivative. Then I'm taking the value of x that's given, I'm plugging it in, and that will tell me what the slope is. So the answer to part A for 38 is m equals 112, assuming I've done no silly math error along the way. For part B, I need to find the y-coordinate of a point, because in order to do the equation for a line, I need a point and I need a slope. The slope I just figured out, the x-coordinate of the point that is given, the y-coordinate of the point I get by plugging 1 in for all the x's. So the y-coordinate of my point for 38b, I'm going to take the original function and change each of the x's to 1. And whatever that simplifies to be is going to be the y-coordinate of my point. Don't care to do that by hand, so I'm going to go 4 times 1 cubed times 3 times 1 squared plus 7 times 1 minus 5. You press one button wrong, then all of a sudden you get the wrong y-coordinate. But assuming I've correctly entered it here, and on my calculator the y-coordinate of the point is 20. So now I have a full point. The x-coordinate that was given, the y-coordinate that I figured out just now, and now I'm going to find my equation by doing y minus the y-coordinate of the point equals m times x minus the x-coordinate of the point. That's going to give me y minus 20 equals 112x minus 112, to clear that parentheses. I'm going to add 20 to both sides. On the left-hand side, that's easy, but on the right-hand side, I need to do minus 112 plus 20. And that's going to give me minus 92. So I'm going to get y equals 112x minus 92. That's going to be the answer to part B. So for 38b, I'm going to get y equals 112x minus 92. Alright, so hopefully you can do 37. It's exactly the same kind of problem. You don't really need the product rule to do the derivative, but you certainly can use the product rule to find the derivative. So a couple more problems to go, and I did some of these derivatives already, and I'm fishing through my work to find these derivatives so that maybe I can get by without doing the derivative again. So as I flip through my work here, oh, beautiful. Crap, organizer. So let's move on to 39 and 40, and I'm going to be uber lazy. If you look at problems 39 and 40 and you compare them to problems 15 and 16, you'll notice the functions are the same. That's not a coincidence. I wanted you to not have to compute the part A derivative again, and I want you to just use your answers. So if you have your work for problem 15, the first step in problem 39 is to find the derivative and then plug the number into the derivative that's given. Well, heck, if you have your answer to 15, that derivative is not going to change. So you could use that derivative. So when I do problem 40, I'm going to use my answer to problem 40 for the beginning part of problem 16. So when I go to do 16a, for 16a, I'm supposed to find the derivative and then plug 2 in for x. Yuck. I can find the derivative by using the quotient rule. But that's exactly what I did when I did problem 16. If I look at problem 16, I did the derivative using the quotient rule. I don't need to do it again because all I need to be able to do is know what the derivative is and plug a number in. So for 16a, to find the slope of the tangent line, I'm going to use the answer that I already created just to save myself some time. That was kind of what I thought when I wrote these, that I didn't want you to do a million more derivatives. Ugh. So let me figure out what that denominator is. I don't want to do any of the math by hand now because I think I'm going to mess up. So the denominator is 3 times 2 plus 11 squared. It's 289. I don't think that fraction reduces. 89 divided by 289. Yeah, it doesn't reduce. What I did is I divided 89 divided by 289, got the decimal, I hit my math button, and then enter twice, showed me that the fraction doesn't reduce. So the answer to 40a, no longer 16, the answer to 40a is m equals this ugly fraction, 89 over 289. To do part B of number 40, I need to get a slope and a point. The slope is this ugly fraction, 89 over 289. The x-coordinate of the point is given. The y-coordinate of the point I get by plugging the value of x that's given into the original function. And again, I'm going to be ultra lazy and do this on my calculator. So I'm going to find this number by going 7 times 2 minus 4, put the entire numerator in a parentheses, divided by, put the entire denominator in a parentheses, 3 times 2 plus 11. So numerator in a parentheses, denominator in a parentheses, and then decimal, then math, and enter twice. This comes out to be 10 over 17. I could have done 7 times 2 is 14 minus 4 in the numerator, and then 6 plus 11 in the denominator, and gotten 10 over 17 just fine. So it's really unfortunate. I'm going to heavily weigh on my calculator now. I'm going to go to get the answer, y minus the y coordinate of the point equals m times x minus the x coordinate of the point. So that's the work that I needed to do. I found the slope and the point. Now y minus the y coordinate equals m times x minus the x coordinate. Let me clear the parentheses on the right hand side. I have to multiply 89 divided by 289 times negative 2 and math enter enter. When I clear the parentheses on the right hand side, I'm going to multiply the fraction by the x and just get that fraction times the x, and then the fraction times the minus 2, which I did here, and that gives me minus 178 over 289. Now I'm going to add 10 over 17 to both sides. Don't care to do that by hand. So on the right hand side, I'm going to go minus 178 over 289 plus 10 divided by 17. Math, enter, enter. That gives me minus 8 over 289. So when I do the algebra, on the left hand side, the fractions cancel, I get the y's. On the right hand side, I still have the 89 over 289x. And then this part combines to be minus 8 over 289. Not that I could probably write that with this marker. I'll write it over here better. So the answer to part B, so for 40b, the equation I'm going to get is y equals 89 over 289x minus 8 over 289. Yuck. So your problem 39 is probably equally ugly, but give it a go. And we just have one more problem to do, and maybe I'll do 41 and not do 42 just so you can, if you need the help, you can get it. So last problem in this section, I'm going to do part A. If I could, I don't think I did that derivative, so if I did, I'm just going to find the derivative. So part A of 41, I need to find the slope of the tangent line, which means I need to know the derivative. The derivative, I need to know the numerator, which is 9x. The derivative of the numerator, which is 9. The denominator is x minus 5. The derivative of the denominator, which is 1. To find the derivative, which I can use to find the slope of the tangent line, I'm going to do the quotient rule. So for 41a, I'm going to write y prime equals the denominator, which is x minus 5, times the derivative of the numerator, which is 9. I can write it after, but it's probably nicer to write it before. It's probably easier to see the simplifying. You could always flip-flop the order. Instead of writing the derivative after, you could write it before. And then minus the numerator, which is 9x, times the derivative of the denominator, which is 1, all over the denominator squared. That's the start of the derivative. Now I'm going to clear that parentheses that I have in the numerator by going 9 times x and getting 9x, 9 times minus 5 and getting minus 45, and then minus 9x times 1 is minus 9x. I'm going to cancel the 9x's and get the derivative as minus 4x over x minus 5 quantity squared. I need the derivative to get the slope of the tangent line. To do part A of number 41, to get the m, I'm going to take the value negative 3 and plug it in for both of the x's in the derivative. So I'm going to go negative 4 times negative 3 over negative 3 minus 5 squared. Don't care to do that by hand, but you can. Let me do it on my calculator. So on my calculator, if I did negative 4 times negative 3 divided by parentheses negative 3 minus 5 squared. When I say negative, I use the minus in the parentheses. When I say minus, I use the minus sign. So I did negative 4 times negative 3, both using the negative on the bottom row, and then negative 3 minus, so there's the minus goes there by the 5 squared, and then bam, math, enter, enter. So I get 3 over 16 for the answer to part A. Being completely lazy, I don't care if you use your calculator to do the grunge work. I kind of prefer it. So the answer to 41A is going to be m equals 3 over 16. I'll move on to part B. For part B of number 41, I need a point and I need a slope. The slope is 3 over 16. The x-coordinate of the point is given at negative 3. The y-coordinate of the point I need to get by plugging in the x into the original function. And let me just pull another sheet of paper to do that because I'm running kind of shy on room here. So to get the y-coordinate of the point for 41b, I'm going to take the negative 3 and go 9 times negative 3 over negative 3 minus 5. This is going to be negative 27 over negative 8, which is 27 over 8. Would probably do this on my calculator as follows. I'd go 9 times negative 3 divided by parentheses negative 3 minus 5. Math, enter, enter. And I get 27 over 8 again. That's the y-coordinate of the point by hand and by calculator. So 27 over 8 is the y-coordinate of my point. So I have everything I need now to get my answer, and I've got ugly fractions with my calculator to take care of those. So now to get the answer that I need, I'm going to go y minus the y-coordinate of the point equals m times x minus the x coordinate of the point. I'm going to get a double negative that I'm going to change positive. So y minus 27 over 8, which is the y coordinate of the point, equals m, 3 over 16, times x minus the x coordinate of the point. That double negative I should make positive, so I'm going to get y minus 27 over 8 equals 3 over 16 times x plus 3. And then if you can't multiply 3 over 16 times 3 and get 9 over 16, you can do it on your calculator. So I go 3 times 3 divided by 16. Math, enter, enter. The right-hand side, if I simplify it, multiplying 3/16 times x, I just get 3/16 x. And multiplying 3/16 times 3, I get plus 9 over 16. Yick, I'm out of room here. So where I'm living right now is I almost have the equation. On the left-hand side, I have y minus 27 over 8 equals 3 over 16x plus 9 over 16. 9 over 16. I'm going to add 27 over 8 to both sides. That's going to give me basically my answer. On the left-hand side, I'm going to cancel the 27 over 8s. On the right-hand side, the x part's not going to change, but the number part is. And to change the number part, I just do 9 divided by 16 plus 27 divided by 8. Math, enter, enter, and I get plus 63 over 16. So the answer, the 41b, is exactly that. The equation of the tangent line is y equals 3 over 16x plus 63 over 16. Oh, that's the whole section. My video now is about a half hour longer than the last time that I did it, so hopefully it was better than my original attempt. All right, so you need to get really comfortable with the product rule, not as much the quotient rule to do section 2.3, but being real comfortable with both is going to be important on the test. All right, I'm just going to pause this thing.